It's fairly accurate. It gets most of what I say. Should be. Okay, so we're recording now. Let's share my computer. If you are ever in Teams and you are wanting to share things, make sure you share your entire screen, because if you click a Chrome tab or a window, when you switch out of that, it doesn't record that, any of the stuff you're doing outside of it. And you'll think people see what you're doing, and they don't. All right. So back over here. All right, so this on that we have typed is part 0. And I'm sorry, I didn't think to record all that before we started, but we'll start from there. So let's look at part 1. Part 1, and yeah, I know there's not a lot of directions here because I knew I was coding it with you. So that's the reason it's just code and examples, because we're going to do it together. In the future, if you want me to start putting directions with the labs, let me know. But I'm lazy and didn't type them because I knew we were doing it together. If the assignments don't have enough directions, also please give me that feedback. All right. So part 1, we're going to introduce turtles. So I told you that we were going to start playing with the turtle module, and that we were going to learn to draw pretty pictures, very simple pretty pictures with our turtles. So first thing we need to do is we need to import that module where Python knows that we're going to want to talk to our turtle. So above main, because I want it to be active for the entire file, I'm going to do the command import turtle. Note, import, def, for, in, those are all in orange, right? So that means that they're keywords that are part of the language. They do something important. Don't make a variable that have these names, these words. Will Python let you? Yes. Don't do it. You'll confuse yourself. You'll confuse the next person looking at your code. Some languages won't let you use keywords as variables. Python will let you do stuff it shouldn't. Loosey-goosey programming. All right, so I'm going to import it before I use it. I'm just going to come in here and I'm going to put a little space in. And notice that I tabbed out, where now I'm in line with the F and 4. That tells Python that I am no longer adding code to the for loop. I am doing something new. So in this case, I want to create a turtle and tell it to go forward and all that. But before we can do that, we need to create a screen for the turtle. Why is that not in there? It's not the most updated one. Okay, so I left some steps out. So let's fix that. So I remember in the slides, I told you that we had to create a place for our turtle to live. So we got to do the screen. The screen line didn't get put in this, and this is a copy paste mistake on my part. I'm sorry. So the first thing we're going to do is we're going to create a world or a screen or something for the turtle to live in. I'm going to call it world just because why not? Of course, now the command's not coming to mind. When all else fails and your mind is completely blank, remember you can always go, well, sometimes you can go to a blank Google document and go, how do I create screen turtle Python? And oddly enough, it will pop right up. Huh? Yeah. Sometimes it's right. Don't always count on it being right, but sometimes it's right. Now, when I told you all that stuff about not using AI to write your code, I mean, don't copy and paste my assignment in and have AI write it all. Googling the format for a single line is something we all do. I've been coding longer than y'all have been alive. I got my CS degree in 1999. So, and I've mixed my Java notes because Java would have done this differently, but not radically differently, just a little bit differently, just enough to not be right. So when you do this, notice the screen in this one is capitalized because it's special case. Normally, you don't see a lot of caps of names of things capitalized in programming languages, but some things like turtle, screen, things like that, those are what we call, oh, brain just went dead. Anyway, they're the special functions that create objects, and my brain will come back with a word in a minute. It's getting old for the birds. Y'all stay young forever because it's so much better. So much better. All right, so that's going to create our screen. Then we need to create a turtle. My example calls the turtle T because I was lazy. You can name your turtle anything you want to name your turtle. I used to make the joke that I named my turtle Tommy. And a lot of people do because Tommy start T turtle. I do it because my older brother's name is Tommy, and this is the only way I get to give him directions, and he has to follow them all. You know, older siblings, they never listen to. So it's also going to come from the turtle module. So the turtle module is going to call it. It's a special case again. So we're going to use a capital turtle, right? Yes. All right. So if I run this now, I'll have a screen and a turtle. So what it did is it opened up a different graphic window and it put a turtle in the screen. Turtles always start in the center of the screen facing to the right-hand side of the screen if you're looking at it. Right? Yeah. It's bad when you have to do your left here. This is important because sometimes you need to know which way your turtle's facing. Yes. Uh-huh. I remember when I said you can use any IDE you want to, but I won't troubleshoot your other IDEs. This is why you should use my IDE. Yeah, there is a command that'll keep it open. I don't remember it off the top of my head, but Google. Yes.
I was gonna ask if we're using one of your laptops, do we save our file under OneDrive?
If it'll let you, it probably would be the best place to save it because then you can get it from other computers. If you don't, it's going to be in your VLab, and when you log into VLab, you can get it again.
Oh, so it'll be in the
It should be. Well, when you log into VLab, it's just gonna log it in like you're in there. It should be on the desktop when you log back in.
Even if I get a different computer.
It should be, because it's stored in the cloud under your login. Yes. It's fine. Is that what you need? Yes, sir. Check your indents. All right. So we're starting to see that it's really easy to get errors. Simple typos will give you an error. Different IDEs do things differently. Sorry. Which one are you using, by the way?
Yeah. I had to look up to make it so that for didn't go away, like the screens and dot exit one click.
Yes. That's exactly it, but I couldn't remember that off the top of my head. Well, you'll see it pop up in some of the examples probably later, but I've been doing it in idle for so long, I just. All right, so now that we have our turtle, let's do something with our turtle. So the first thing we're gonna do with the turtle is just have it move around. So let's make Tommy go someplace. We're gonna make it go forward 100 pixels, and then let's have him turn right 90 degrees, and then forward again. I don't usually use the turtle.done, but we will for right now. So now if we run it, theoretically, he should draw two lines that are at a right-hand angle to each other. Right? Now, what did turtle.done do? Nothing that you see. If you leave that off, it's not going to affect anything. If you're in idle and you want this screen to go away, you can close it here, or you can close it here. Either one of those X's will close and wipe the graphic. So once we've done that, we can start talking about part 2, which is drawing a square. Well, you don't need to import. I really uploaded the wrong file. I cleaned this up. I swear I did. I will go re-upload the other one because you do not need import again. Why did I do that? This is what happens when you have way too many things going on. All right, so if we go and do part 2, which is drawing a square, this is where our for loop comes in. Just all we care about is the for loop part. We already have the other stuff. We already have a turtle we've already imported. I'm gonna be honest with you. I asked Copilot to clean my thing up and it did not help me. Don't use AI. AI did not help me at this point. I'm also going to get rid of turtle.done because we're not done. We're going to add something to it, right? So now if I put a for loop in, and since we are drawing a square, how many sides does the square have? So we want to repeat these steps 4 times, right? Because we can do this in a loop this way because a square has equal sides, equal angles, so nothing has to change, right? Geometry. If it was a rectangle, it wouldn't work. So we can now come down here and being that I'm lazy, I'm going to copy these lines of code. But be careful when you copy paste because it does not copy paste the tabs correctly. So you'll have to clean the tabs up. So I know that for a square, I want it to go forward. Then I want it to turn 90 degrees and go forward. And then I want it to turn 90 degrees and go forward. Right? And if I do those two lines of code 4 times, I should get a square. Yes?
Yes, that makes.
So it did the first two lines I told it to draw first. And then from there, it drew a square. Yes?
Yeah.
I got a no going. Yeah, is it you don't understand it or the code's not working? Okay, go back to the code. So you can comment this out if you don't want the L to draw first and you just want to test the square. So if you want to just test the square. Okay. So I know that worked. We did it. It worked. So I'm just going to test the square. And before I turn it in, I'll go take all those out where they're not red, where they'll be graded, right? But as far as testing goes, I get it out of the way and I don't have to wait for those two lines to draw before I see the square. So we need 4 sides and 4 turns to make a square. Our loop's going to run 4 times. We're going to go forward, then we're going to turn. We're going to go back and do the loop again, and we're going to go forward, and we're going to turn. And then we're going to go do the loop again, and we're going to go forward, and we're going to turn. Now, technically, we don't need that last or that 4th turn, but if you put it in there, then your turtle is back facing the direction it was facing when you started, and that will help you out immensely when you get ready to draw the next shape because you know which way your turtle's facing. There's a method to my madness. It's not often, but it's true. So if we do it without the part 1 part of it and we just do part 2, we just have a box. Now, as we get more into turtles, you'll learn how to color that box in and change the line colors, things like that.
How did you get just the box again?
I just commented the other lines out, so I just put
Oh,
the
numbers?
hashtag. Yeah,
Hashtag?
number sign, hashtag, whatever you want to call it.
Hashtag.
Yeah. So if you put that in front of it, it turns the words red, then it means that the compiler is ignoring it.
Oh, like it's kind of deleted.
Yeah, except you didn't delete it. So when you want it back, you don't have to actually like retype it. You could just remove
The
the.
numbers.
Yeah.
Okay.
I do this a lot. This is how I test individual pieces to see if they're working. Or if I added a bunch of code and it broke what I already had, then I comment out the new adds and uncomment one line at a time until I see what broke it. This is what we call manual debugging. You're not using a debugger, you're doing it yourself by commenting code out. Now, absolutely, you could just delete everything you just wrote and start over, but save yourself a little bit of time and see if you can narrow it down to what the one piece is that's broke instead of eliminating half an hour's worth of work or whatever. Are we good? Y'all ready to try a different shape? All right, to separate our shapes out, I'm going to put a go-to in. So Tommy, go-to, and I'm going to move him to And I just randomly picked numbers that's gonna move him up and over. So you can put whatever numbers you want to in there as long as you stay on the screen. And now the next part of our, oops, is to draw a triangle. The easiest triangle to draw is an equilateral triangle. That means it has equal sides and equal angles. Can you draw other triangles? Absolutely, but there's math involved. And I don't know about y'all, but digging up the the depth. Yeah, digging up those theorems is not going to happen. So again, skip the where we create the turtle and we do the import and just do the for loop. For I in range. Now, triangles only have 3 sides. So we need, this is what I'm talking about, the yellow box, so that gives you suggestions. So you can use range 2 ways. You can just put a stop number in, which is what we did, or you can put the stop, start, and the step in, which we don't need for this case. But so now we want to go forward again. And then we need Tommy to turn. Now, here's the thing. When Tommy's trucking along on his forward path, you've got to know what angle to turn at. Well, we know on an equilateral triangle that the interior angles of the triangle are all 60 degrees. But the turn the turtle has to make is not the interior angle, it's got to make the exterior angle. Because he's going on a straight line this way, now he's going to turn down to the triangle next leg. So I'm going to tell you that that would be 60 minus 180 because a straight line is 180. So therefore it's 120 degrees that we're going to turn. Now, if you were doing a right triangle or a isosceles triangle or any other triangle, you would have to stop and calculate what that angle is. And you can do that 2 ways. You can do it doing the math, which to me is easiest, or you could do it trial and error and you just keep punching in numbers until your turtle turns where you want it, which is the brute force method. You're just going to keep pounding the turtle's head against the wall until you get him where you want him. It takes a long time, but it does eventually work. Just keep that in mind. And the internet is more than happy to help you find the math to do these things. So we're going to turn, oh, we said left in this one. So we'll do a left-hand turn just to show you that we can do left and rights. So this time he's going to go forward, and instead of turning to his right, he's going to turn to his left. Doesn't matter whether he turns right or left. It just means that the point of the triangle is going to be up instead of down. So I'm going to run it now, and I should have a square and a triangle. This line is because I said go to without picking up his pen. I did that intentionally. I'm going to show you another command in a second. Yeah.
One line when I did it. And I saved it, saying that it wanted to run it because it's not saved, but I saved it and this popped up when I hit runs.
It's running. You just don't have any output.
I don't have the output.
So show me your code. What are you missing?
Oh, main at the end. Does that
So you've defined it all, but you've never actually told it to run.
why not put it? Does that have to go at the end of every code that we do?
It has to go at the end if you want main to run. If you have a main function, it has to be called. Yes. I put it at the end. You can call it other places, but you don't want to, because then the stuff behind it. Yeah, we talked about this a little bit at the beginning of the class, I think, before you got here, so. Fine. No biggie. So this go-to, you noticed on mine when I ran it, I told it to go somewhere and it drug the pin with it where it went, right? So you just have a random line. Well, that's not very pretty. You don't really want a trail everywhere you go. So before you do that, to make it cleaner, you can put in, oops. So before you can tell it to pick its pin up, and then after you move, you can tell it put its pin back down. Now let's see if I remember the Python or the Java code for that. Yep, I did it right. You also can use pin up and pin down, but why type the word pin when up and down works? So now we have a square and an equilateral triangle. Are we having fun yet? I'm having fun. I've made a lot of really bad jokes in this video, so y'all just ignore my humor. I can't help it. I'm a parent. My husband makes the most horrible dad jokes, and I guess I make mom jokes. Or maybe they're teacher jokes. I don't know. There's something. All right, so now we've done a box and we've done a triangle. The next one is circle. I'm gonna be honest with you. Circles are really, really hard to draw. Really hard. Because pixels are not round, and you have to tell it to move and turn and move and turn and move and turn and move and turn and move and turn a lot. So luckily, oh, that's a house. I went too far. Where's the circle? There's a circle. There's a function already built in Turtle that does circle. It's really convenient. I love that. And I used to be really evil and assign y'all to do a circle and then expect you to go find this function. But I found that a lot of students are stubborn, and rather than going and looking in the documentation for circle, they try to create their own circle. And so I'm going to save you some headaches. So in this case, we're going to do a circle. Do we want to move over again? So I'm going to grab my move code. Let's see, let's change this to, well, we'll go ahead and go up that far. We'll change this to 200 or something where it'll be further over. I'm gonna put a bunch of inner blank spaces in where I can move this back up to the top of the screen. The main is still down there. I just moved it way far down the screen. It's still there, I promise you. And now we're gonna do 4. Well, we don't need a 4. Using the functions. What am I thinking? So Tommy's just gonna call a circle. Now, why did I put 50 in? I've been using 100. Most of my things have been based on 100 pixels. It's the radius of the circle, not the diameter. Radius is half the width or half the diameter. So, and once I get this circle drawn, I'm going to talk to you a little bit about logistics of, because if you ever want to place one, you're going to need to know a little bit more. So let's run this again with our circle. Now, you notice when that drew, that it drew from the starting point and it does it really jaggedy because this is low resolution graphics and it's showing you some of the pixels. But it went back to its starting point. So you need to think about where your circle is going to start when you go to draw it. All right. So logically, I would, if I didn't know this because I've been playing with this for a lot of years, I would have thought that the circle would have started, I would just assume would have started at the top and worked around. That's not how it works. It starts at the bottom and it actually draws counterclockwise, which is just weird to me. Yeah, I can do it again. Let's do it again and watch it. And see, me being the American educated child that I was, think circles should always start at the top and go clockwise. Because that's how we were taught to, at least I was taught in school to draw them. So, I don't know who did this, don't care. Somebody programmed it this way, which is fine. They like making left-hand turns instead of right-hand turns. But when you go to start positioning, because one of the things I have you doing for your assignment is drawing me a little scene where you have, the bottom's green and you put a little house on it and you put a stick figure, kind of thing. Yeah. Yeah. I'll go back. Okay. Yeah, too. So think about placement. This is one of those situations where a piece of paper and a pencil, piece of graph paper and pencil, even better, a piece of paper and pencil, and lay things out first will help you figure out where your go-tos need to be. Okay. Did you change the number? You have to change the number or you just moved it on top of itself. So when I did the go-to up here, I did the 100, negative 100, 100. Yeah. So over here, I changed it to 200 where I moved 200 pixels off of. Yeah. So I moved another 100 pixels up, right? Because X moves you this way, Y moves you this way. Up and down for those people that can't see me gesturing on the videos because I'm not actually recording myself. Anyway, so yes, we understand go-tos.
That library that you showed us online, like if you go on and like pull different, I think, different code statements, does it have like a thing where it defines what each of the symbols do? Because I think I need a better way to remember what everything means, like the closed parentheses.
You probably would be better off going back to the PowerPoints and looking at them.
Okay.
It probably is absolutely in that documentation, but I think it would be quicker for you to find it by watching the video that I did of class Tuesday or going back to my PowerPoints.
That'd be more.
It'll be condensed and less you struggling to find individual things in that very large. Yeah. Also, there's loads and loads of Python tutorials online. So if you didn't get it from the way I explained it, I am not the only person that can explain it. I often will tell you that if you didn't understand what I said, but your neighbor seems to, ask your neighbor because they might say it in a different way than I did. So absolutely go look for other explanations. That's a good use of AI. Could you explain to me what the parentheses do in this line of code?
Right.
Because they'll explain it a different way. May not be 100% accurate because AI is only as good as the information that it's been trained on, but it does give you a different perspective.
Like a different way of saying it.
Yeah. Because back in the dark ages when I was teaching high school, my thought process on this was, I haven't been your age in a very, very long time. So I don't think and speak the same way you guys do. You really don't want me using your slang. And I've never been a young gentleman. So, and I know it's going to get me in trouble, but there are very different ways people think. I'm a visual learner. My oldest child is dyslexic. So he's an auditory learner. He has a visual processing problem. I can't explain things to him because the way my brain sees it is not how his brain sees it. So it just depends on what your learning style is too. Somebody else with the same learning style will do things differently than I do. And I do try to incorporate several different types of learning styles into all of my presentations. But I am biased towards my learning style. Can't help it. It's just human nature. Yes.
Starts always draws up or flip it, like before he draws a circle, if you flip them 180 degrees, then he'll start at the top.
Right, but he's always turning left. Because it's the direction the turtle's facing. The turtle is going to go to its left. So that's probably a better way of saying it, yes. So the turtle's always going to draw with the circle. So what he's saying is if you flip your turtle over and he's facing the other direction, it does draw it down. But if you think about it from the turtle's perspective, he's always going to turn to the left on a circle. Now, I'm sure somebody out there has written code where he turns to the right, but I'm not going looking for it. So circles invariably have been the bane of existence for people trying to position them. So let's talk about this window, your graphics window here. If you have this window here and you think about it from your middle school, high school math classes, and you think about this as a piece of graph paper without the lines on it, right? If you draw yourself an imaginary X and Y axis, and I can't do it with my finger, on this, across here, so this would have been the center, because that's the very first place we drew. That's where our turtle. That is position 0, 0. As the turtle goes up the screen, Y gets larger. As it goes down from that center point, Y becomes negative, just like if you were graphing in math. The x-axis runs this way, 0, 0's here. As you go to the right, it gets larger positive numbers. As you go to the left, it's negative numbers. Yes? So when I do those go-tos, if you think about that, I'm at 0, 0. If I wanted to go to this corner up here, then I'm going to go negative X, large positive Y. So that would be like negative 300, 300. Why do I know that? Because I've used this example before. If I went to this side of the screen, then I have two positive numbers. Now I'm going 300, 300. Down here, I have positive X, negative Y. And in this corner over here, I have negative, negative. So if it helps, and it will help, especially if you're like me and you're a visual learner, just draw your little box with a cross in it when you're planning things out and think to yourself, what are my numbers going to be? Yes? Yes, you can ask the turtle. If you go back to that list of functions that we did for the turtle, which is linked in the PowerPoint, or we'll just pull them up real quick. Where's my internet browser? So I can go in here and I can do turtle API Python. And these are all the functions that the turtle can do, but I like the search bar. So much easier. So position. Oh, it didn't, yep, there it goes. So turtle position, you can go in there and look at it, but there is things in there. There's one called XCOR, XCOR, that'll tell you the X coordinate, just the X coordinate. Y core exists, it tells you just the Y coordinate. There are some that'll tell you the whole position. But go to turtle.pos, because we had to abbreviate. We'll return the coordinates of where it's at. And yes, it will do a fraction of a pixel if you really tell it to. But it's kind of like a GPS coordinate system for your turtle. The turtle knows where he's at all the time. So it'll give you its X and its Y location. How useful is that? It can be very useful, but you'll have to put it in a print statement where it will print to the screen and tell you where you're at. XCOR will tell you if you want the current X coordinate, you can use it in positionings. It'll go get it, use it. So, but this whole page right here will give you all the different things you can do with where the position of the turtle is. And my goal for this class is not to have you memorize every line of Python code. My goal is to teach you where to go look for the lines of Python code you need and use those creatively to come up with new programs. Don't reinvent the wheel, but do invent new code and new programs. So instead of being consumers, we're going to be producers of technology. Yes, ma'am.
So we don't plug in what's on the website exactly. We just kind of take what they give us the example.
These are examples. So these numbers are not going to help you at all. You're going to have to come up with your own numbers to match your program. You're going to have to know how this works, because if you just copy and paste random code together, you're not going to get the desired result you wanted. That's how it's really easy to find out when y'all have used AI or not, because unless you copied and pasted my entire example into the AI program or my entire assignment, in which students have done, and it will spit out code, not good code, but it will spit out code. It's not going to know what I want. So that's the reason a lot of your assignments have very vague directions on them now, because I was giving much more specifics, and it was very easy for the AI to generate that because I gave so much information. So now that's why I'll say you'll get stuff that says using the stuff we worked on in class. This AI don't know what we worked on in class. And that's also why I'm not going to let you turn in anything that we haven't learned in class yet, because the AI program should generally give back much more advanced code, because it's more efficient and it's advanced for a reason. All right. So that does that answer your question in the back about coordinates? Okay. All right. So back to where we were. So now we've got a circle and we've got a square. We've got a triangle. Let's make a house real quick. And because I want us to get into a different part of the screen altogether, let's go to the opposite side of X. And we'll go down Y to get us, maybe that'll get us, well, we'll change the number, make sure we get. I'm trying to get to a clean spot. So now I want to draw a house. Well, I want to draw a house by making the bottom of the house a square and the roof of the house a triangle, right? So I'm going to move to 200, negative 200. And I'm going to draw the base of the house first, because that's, to me, that seems like the way to go. Could you draw the triangle first? Absolutely, doesn't matter. Your code, do it in the order you want to. But for this example, I'm going to do the box first. So I need 4i in range 4. So then I'm gonna draw the square. We've been using 100 so far. Do you want to make this house bigger than we've been making? You want to make it smaller? You want me just to show you what it does? I'm gonna try some different numbers. We're gonna make it 150 pixels this time. That way you can see the difference. Oops. The square, so we don't want to change this number because squares have 90-degree turns. So remember, in right and left, we're putting in the degrees we want them to turn. All right, and once I've got that, I'm gonna backspace out because I'm out of my for loop now. And let's think about it. This is going to draw the square. And it's going to put our turtle right back exactly at the top of the box where we started from. So I can just immediately start drawing my triangle now, right? As long as I make sure that I turn left instead of right, where the point goes up. So I don't even have to move him because he's in the right place. I have to make it 150 also, or it won't match up to the base of the house. And this is where you knowing what direction your turtle is facing is very important, because if he was facing the other direction, then I would need the triangle. If I wanted it to point up, I would need to turn right instead of left. I find that when I'm drawing with the turtle, sometimes drawing it with the pen and going, okay, am I trucking along this way? Am I going right or left? You know, and I just do it on a piece of paper and talk to myself. I talk to myself a lot. I'd like to say I just talked to my rubber ducky, but I don't. Now, he drew the bottom of the triangle directly over the top of the square, but who cares? So it's a house. So, and your assignment, because that's all the lab. That's the completion of the lab. And your assignment that you're going to go home and do on your own, I ask you to create me a scene. Actually, let's just open it up and look at it. You want to open it up and talk through it before you go home and do it?
Yes.
Okay. I'm easy peasy. Yes, I can. Sure. Yes. Let's do this first. All right. So the objective is up here. You're gonna use the turtle module, blah, blah, blah. Just, yeah, I have to put it on there. It's kind of required. All right. In part 0, remember you need a main for your code and call main at the bottom. I'm going to start trying to put that on all of them to just remind you to do that.
Yeah.
Part 1, that's not a touch screen, but this is. You're going to draw a simple house. You're going to have a square for the base of the house, just like we just did. You're going to have a triangle for the roof of the house. We just did. Guess what? That's your code. You wrote it. Copy paste it if you want to get started with your own code. As long as you understood what it did. That's why the labs look like. All right. Use at least one smaller square inside of the large square as a window. So use go to, put yourself inside of your house and draw me a tinier square. That means you're just going to change the width of your square, right? That make sense? And a small rectangle for the door. Now the rectangle will not necessarily be a loop. You could just write the lines of code to do that. You don't have to use a loop to make the rectangle. But you do know how to do forwards and turns and stuff enough to draw a little door in there. The hard part of part one is guessing or calculating where to make your go-tos. Can you make your house bigger than 150 pixels? Well, you know, I use 150 pixels. Absolutely. But just remember that after part one, you have part two. So maybe read the whole thing before you start getting really huge. Part two, we're going to enhance our scene. Fancy words for we're going to make it better or add to it. A stick figure. Circle with lines coming out of it. Stick figure. Don't get too elaborate here. 2 arms, 2 legs, body and head. Like we're playing hangman. If you want to put a face on it, go for it, but not required. Might impress me, but not required. Look in the API and see if you can figure out how to fill a square and make a large square at the bottom of your screen and make it green to indicate grass. Yeah, you're having to think and work. I know. I did put this in parentheses. I do not expect you to make individual blades of grass because there will be some art major in here that's going to try to make this look like real grass. No, just green. Yes.
I was just gonna ask, wouldn't the grass be like a rectangle so it can cover the whole ground?
Right. But it doesn't have to be a loop. You just have to figure out how to get it. There's also some settings where you can change background color of the screen. So you might play with that. I don't know how you're going to do it. This is the challenge portion where you get to go and show me your creativity and what you can find. I got a couple of 3 people in here that I know have had programming classes before. They're going to do it completely different than the rest of you did it. Don't get too elaborate though, guys. Try to stick within the framework of what we've learned in class. Yes, there's 3 of you that I'm looking at that I kind of feel like you have some experience with this. Just based on what you said in class. All right. Use loops where appropriate, but you don't have to use loops for all of it. This doesn't mean leave loops out of it. There should be some loops in your code. That's what we've learned this time was loops. The creative challenge portion of it down here in part 3, you can add some clouds to the sky. You could add a tree and a tree trunk with a little ball of green on top of it for all I care. Add the sun, add some flowers, just pick something and add to it. Do you have to do all this? No. Pick one or pick something to add to it besides the stick figure of the house and the green grass. Maybe you color the sky blue and you put a couple of fluffy clouds in it. I don't care. Fluffy clouds can be created by drawing circles on top of each other. Now, I am going to give you one piece of advice. Or not really advice. I'm going to tell you something that we haven't really talked about. You need to draw things with the thought of whatever's going to be in the background has to be drawn first. So I know I told you to add the green grass as part 2, but when you go to write the code, put it in order higher than the house, because if you don't, the green will cover over everything you've already drawn. So the order it draws in is important. It does it on top of each other. Think of old Photoshop layers. Make sure that the layers are in the order you want them to be in, because you can always just go back and insert stuff into your code. Does that help?
Yes.
Do you all feel like that you can go forth over this long weekend and create me a scene It is a house and a stick figure and maybe a tree or a sunshine or something. Now, if you don't get all the parts working, I will give partial credit for every part you do get working. All right. If you don't have any other questions, we are at time. If you want to talk to me about assignment 2, stay put and I will open that real quick. This one, is this the one you're talking about? So the ASCII art assignment is just a series of print statements and input statements, right? So looking at this output, each row of A's and Anna, A's and Anna's, is a print statement.
I about this too.
I meant to answer you and I have not. You use the thing where you can print multiple lines.
Like 3 quotation marks, made it big, like art.
That's okay. I haven't actually taught that yet, but that's okay because that's easy. That one's easy enough to look up. So you have 1, 2, 3, 4, 5, 6 print lines, print statements to create this graph. Now you can make it bigger or smaller. This was just the example I did when I was writing this. So all this is print, open parentheses, quotation mark, space, 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 A, space, 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 N, space, 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 A, space, quotation marks, close parentheses. The next line is one less space, A, space, A, space, 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 A, N, space, space, space. So the blank spaces are actually hitting your space bar between all those letters. Is this tedious? Absolutely, but it's not hard. Don't overthink it. It's not hard. It's just print statements. I'm gonna do one real quick. Tonight, I hope. You just email me if it doesn't get posted tonight. Because my brain is shot. So, just because I have this open already. Oops. You should, yeah, submit the lab and course in if you're done with it. So this is just a print statement.
Oh, so you literally like typed out how you want it to look.
I literally have to do it this way.
And then it prints whatever's in the parentheses.
Mm-hmm. Prints whatever's in the quotation mark. So now if I run this, you guys are making me think hard today. Ignore the red stuff. I made the turtle stop because I didn't want to wait on it. Those 2 print lines made that, which is the top of the word Anna, right? But you can't use Anna because that's, unless your name is Anna. If your name's Anna, lucky you. You need to use the letters from your name to create this. Now, if you have a super long name, pick 3 or 4 characters. Your initials, if your name is Gabriella or something, don't do all of it. Just do Gabby or Gab, or use the 3 initials that you normally would use on legal documents, but at least 3 letters. tedious, but not hard.
I did.
Huh?
I did.
That's fine. You can do more, just don't do less. All right. Does that help? Okay. Let me stop this video because I don't know where it went. Never mind, the operation was not complete because, oh, hey. Teams may not have been recording all this. We will see, though. We will see. No, it says it's recording over here. I don't know what that was. Okay.